Okay, let's start. Hi, we are Luis Mineiro
Just running away from that.
Sean Floyd from Zalando, originally in Germany, but actually now spreading around the European continent and perhaps eventually the world. We will be talking about auto-scaling your API, and we will be covering that from two different angles. I will be covering that from kind of an organizational management angle, and my buddy Luis will cover it from the ops, DevOps angle. So we're gonna show you a lot of different aspects of what we're doing and where we're doing it, and I think it will be fun. So let's start. So first of all, we've realized that most of you don't know who we are, which is kind of a change for us because we're in the western half of Europe. Everybody knows who we are. So I'm going to show you a map of Europe, which looks like this, and you can see all those orange countries are the countries we sell to, and all of those are countries where we have a huge brand awareness. So originally we are a fashion retailer. We started with shoes, but then we expanded to fashion and accessoires and all kinds of things. We do everything ourselves. We have three logistics centers. We have our own front end, our own back end, our own risk management. Everything we do, the entire stack ourselves. We are currently at 9,000 employees, 900 of those being technology. So we're big and we want to grow beyond that. But this is basically who we are. This is our technical scale. Actually, this slide is old. It's a bit beyond that, I think. But we serve 15 European countries. We have several data centers, but actually we want to move away from the data centers. But this is our historical stack. You can see we have farms of Solrs, hundreds of them. We have the web shop, which is farms of Tomcats again, so again hundreds. We have several mobile apps that connect to this. We have the lounge, which is a separate application where you can buy the stuff that we couldn't sell that well in the web shop. So there's a second round for that with a buying program where you shopping club kind of thing. And yeah, we do our own tooling. We integrate third-party software into our landscape, and we have our own logistics centers. We own the logistics warehouses. We write the software that runs the conveyor belts, and the people who work there are for us. So it's really big scale. Historically, we've done pretty much everything with Postgres. For a while, we did a great job with that. We used to have a very monolithic architecture, and for that, Postgres was fine. But eventually, we're growing to a size where, where having one centralized stack doesn't scale anymore. And this is part of what we're talking about. Anyway, this is the Zalando shop, as we like to picture it. It's we sell stuff and make people happy. Officially, it's called the fashion store, but internally we call it the shop. And this is what it looks like. This is how our website looks like. But we actually want to look at what it looks like from behind. What we actually have is the so-called shop monolith. It's actually, so this is not all of Zalando, this is the front-end part of Zalando, but even that is very, very big. It is...
it's a monolith. It's
a monolith, yeah. And as different companies usually like to come up with different names for their monoliths, even if as they try to get rid of it. So SoundCloud calls theirs the mothership, but we call ours Jimmy. And so what is Jimmy? Jimmy is pretty much this. It's thousands and thousands of Java classes. It's many years worth of features that nobody knows about anymore. There's code in there where nobody knows what it's doing. The project managers who actually wanted that feature have long left the company, so we don't know what it does, basically. That's bad. We have business logic on all layers. We have business logic on the front-end layer. We have business logic on the web layer, on the service layer. We even have business logic in the database, lots of it. Back in the Postgres days, we used stored procedures, and the stored procedures were actually doing a lot of the business logic. So this is really kind of how not to do it. Okay, now something happened. In 2013, well, you know, hackathons were in fashion a lot, and we were actually basically we wanted to do what we're doing here now. We want to reach out to developers, and to reach out to developers, well, hackathons sounded like a good idea. So if you want to go on a hackathon, you need an API. So our bosses basically suggested, can we make an API of this? And looking back at what I just showed you, that doesn't really look like something you can turn into an API, right? Basically what we need for a Hackathon API is a REST API, and the REST API should expose resources in a clear, structured way without business logic. So how are we going to do that? The first step is we created what we called the Hackathon API. And what we did was, inside our existing web application, we just created some more controllers. And we actually deployed the shop to a different server and only exposed those endpoints. It was actually the full monolithic application, but it was kind of working as a REST API, pretending to be something it wasn't. So, yeah, it was a weird hack, but. Anyway, the pro is, okay, we could move fast. We just write some REST controllers. We have the deployment and everything out of the box, and it's a few days of coding. The cons is, okay, this API cannot be deployed independently of our Jimmy application, and, well, deploying our Jimmy application takes several hours, and it's infested with business logic everywhere. There is things, just take my word for it. If I go into that, this talk is not going to be finished on time. Okay, so then eventually, after a few months, some new requirements came up. So we had this Hackathon API, and it was kind of successful. People built cool shit with it, but then eventually our bosses thought, we have a Hackathon API? Can't we just use it for some other stuff as well? So suddenly, well, they had the idea, okay, we have our front end, and sometimes our front end needs to know more about the back end, so we need to have some interactive applications in the front end. Why can't we connect our front end, our JavaScript applications to this API? Well, the problem here is that we have extremely high traffic, and so that would mean we need to scale this to a completely different level. And then also, what we were starting to do was to set up contracts with third-party companies who actually want to build applications based on our catalog. So we also want to provide our catalog data to those guys who want to build their own applications on it. So that's a third use case, which is, again, completely different. Okay, so what we did is we decided we will create something that we call the Shop Public API, and we will build it as a real API, as a real REST API, and as a standalone project. And of course, it did have lots of dependencies. The catalog came from our solar farms. Stock information comes from a Memcached because it has to be very fast. We need to have real-time stock information. Then we have customer reviews, which actually already live in kind of a REST API. You could call it REST, or you could call it JSON RPC, but it's at least a bit more modern than our old SOAP infrastructure. Then we have article recommendations. So basically, would you consider buying this other shoe that goes well with this shoe, or seeing what you bought previously, perhaps you also like this. So we have this very advanced recommendation engine, and that's also working in a JSON RPC way. And then, of course, for some applications we do need the database. And well, all of them are in the same data center, so this shouldn't be a problem. But then something happened. And what happened was that last year, suddenly we announced that we would we would no longer be a fashion retailer, we would become a tech company. Basically, the paradigm shift is we used to sell fashion, and now we will start selling our fashion infrastructure. We will open all our infrastructure to third-party companies that can use our infrastructure, and we will call this fashion as a service. And to do that, we established 5 principles. One is API first, where the principle is you document an API in a non-technical format, so in a description format, before you write a single line of code. So actually we will talk about what will the API look like before we code it. We've established that we will use Swagger for that. We've looked at different other formats, but Swagger is kind of the compromise. And so we write Swagger definitions for REST APIs, and we peer review them, and those get approved before we write a single line of code. This is kind of, so this API first a rule came along half a year after we actually introduced the shell public API, but actually we had already worked kind of like that. We hadn't used Swagger, we had used the Google Doc, but apart from that it was pretty much the same thing. Okay, next principle is REST, and we're fine there in the shell public API. So REST meaning manipulate resources, don't call methods, it's not RPC, expose nouns, not verbs, and use the HTTP verbs correctly. The next thing we want to be, from a company perspective, is software as a service or fashion as a service. There in our shell public API, we're kind of doing that. The problem is we're very limited there because we didn't have an identity management strategy yet. I mean, we're currently working on it, but we're talking about a time about a year ago. So a lot of our backend services, they don't expose APIs. They're in an old service architecture, and in our data centers, they're not available outside. And we did not have a company-wide identity and access management strategy. So we decided that in our public API, we can only expose read-only features for now. So you can do queries for articles, and you can read the reviews and the recommendations based on that, but you cannot put something in your cart. We can't. We'd love to support it, but we can't. Okay, and the fifth rule was we want to do microservices. But what we have is a service-oriented architecture. It's not the same thing as microservices. A lot of those services are actually way beyond micro, and it was mostly SOAP, and yeah, not really micro. And the final thing was we want to be in the cloud. And that actually is a good idea because hosting your own data centers is very, very expensive, and we need to do operations. We're pretty good at development, but we're not that good at operations. So other people are better at operations. So actually moving to the cloud sounds like the wise thing to do. Meanwhile, we have moved some applications to the cloud, but at the time I'm talking about, not a lot. And there were some challenges ahead. The backend services were not available in the cloud. Neither was the Solr. And we cannot move our databases to the cloud. So how did we do it? And this is where I hand over to my buddy Luis.
Good job. That light is killing me. So, Sean just said that we had these problems, right? We need to go to the cloud. The Shop Public API was actually the first application to switch to AWS. And the Jimmy in the data centers is still there, it will run there, and it also needs those data sources that we just mentioned. Catalog and stock data sources are latency critical, so both Jimmy need those data sources, but the Shop Public API on AWS also needs access to those data sources. So, and even worse, we are part of the fashion stores team. Catalog is actually owned by our team, but for example, the stock service is owned by another team. So we cannot just go there and say, hey guys, move this to AWS and also provide us an endpoint so that Jimmy can still access that. So how do we solve that? What can we do about this? Well, it should be easy, right? We move all of the critical data sources to AWS. We move Solr, we move stock, and then it should be easy. Even with some coordination, this should be possible. We can't just move them, right? As I said, Jimmy also needs that in the internal data centers. It's latency critical, usually around 1-2 milliseconds. This is how much time we can afford to query the catalog or to query any stock information. This is exactly the reason why it's a Memcache, because we need that to be fast. So we can't just move them, so maybe we replicate them. This was our idea, we just replicate them, right? But how do we replicate these data sources? Well, we looked into it, and Solr actually already has its own replication mechanism over HTTP. If you guys know or have any experience with Solr, even the old one, because we are still using Solr 3, it does expose a replication mechanism over HTTP, and this would be a perfect fit, because we just set up some repeaters on AWS, and we replicate over HTTP, and then we could figure out firewalling and authentication and whatnot. And Memcached would also be really easy, right? No, actually it's not. Memcached, on the other hand, doesn't provide any kind of replication mechanism. So we need to build one. We need to build some kind of Memcached replication. And this is the first step where it starts getting interesting. This is now the solution that we found for this particular problem. To replicate a Memcache, we created this, which we call a stock relay. So to the left side, as you will see in the data centers, we already have the Memcache cluster with multiple Memcache nodes as partitions. Actually, they are all replicas. There is no partitioning there. All of them contain the entire data set. So if one dies, it's fine. We just lose availability for a bit. But all of them have the same data. So the stock service itself keeps replicating to all of the known nodes, all the mutations to the stock information. So you can always very easily query any of them to get the information for that. So what we built a Memcache proxy. We built a Memcache proxy that for the stock service, it looks like a Memcache node. But the difference is that what it does, it intercepts those deletes and those sets, so the mutations, to the Memcache. And now it does, it serializes this event, pushes this to an SNS topic. You guys know what SNS and SQS is? So it's pub/sub on AWS. On SNS, you create a topic, and then you create a queue that subscribes to the topic, right? So then you have pub/sub. So this is actually what it does. It serializes the mutation event, sends it over to AWS. This is actually really, really fast. I mean, we didn't expect anything else. It's AWS after all. And then we have consumers on the AWS side. So this is pushing really, really fast. These stock changes, because they happen like thousands per second. And then this is serialized, sent over the wire in a very optimistic way using high streaks and whatnot. And then on the AWS side, we run this consumer. This consumer is reading those serialized events, deserializing, and then writing to local elastic cache instances using Memcache also. The biggest advantage here, so we had Memcache here, and now we have Memcache there. And it is as much as possible synchronized with a slight delay. Actually measure this, and it's around 30 milliseconds, which is very, very good. It's okay. And then we can still run the Shop Public API either on the internal data center where we actually started operating, or on AWS, because they still talk to Memcaches. There is absolutely no difference. So we can very easily go from one or the other, or even run on both. So in this particular case, this was what enabled stock information to be available on AWS. But we're still missing how do we finish the replication for Solr, right? I just mentioned that we enable the replication of HTTP, but then what? this is actually a really old school concept. There is nothing fancy here. This strategy has been used on almost everywhere where you need a scaled replication infrastructure, which is you don't have one single master and then you grow a fleet of slaves all replicating from that one. The reason is that at one given point, this poor master or even the network interface is not enough anymore to replicate all of that data. What we do is we put repeaters. A repeater is actually both a master and a slave. So at the first layer is the master, the second layer is this repeater, and it thinks it's a slave because it replicates from the real master, but then it has some slaves replicating from this one. And this is what we call the repeaters. And what we did, we have repeaters on all of the availability zones or regions. Yes, US East, exactly. So we have one repeater on each region, and those actually replicate from the master in our data center. This is not as fast as the stock, of course, it's not milliseconds, but it's reasonable enough. I mean, we already have this delay internally because we run around 600 Solr instances, so there is already a delay for replication. This is just an acceptable cost. We replicate this to each AWS region, and then we run our Solr farm there as slaves replicating from these repeaters. And this is basically how it auto scales, right? Should be no problem. Now we are on AWS. So we have the region repeater there to the left, and then we just set up an auto-scaling group with a bunch of Solr slaves that will grow up and down, and they will replicate from the repeater. And if the shop public API on the right side is also auto-scaling, and eventually it is growing because we have peaks, then it will also trigger auto-scaling events on the Solr layer. And eventually it will grow to hundreds, thousands, and then it crashes and burns, of course, because the setup was just one Solr repeater per region. So we just delay the problem, but eventually we'll have so many slaves in the auto-scaling group that they will kill the poor repeater. So, why doesn't this scale, and what can we do? And then we actually found two solutions. We had two people working in parallel on different solutions. This is one of them. This is actually the one that we have working right now, because it's very simple to operate. This is the easiest thing in the world. We just changed our Solr setup with some scripting and stuff, and what we have is we have the master in the data center, the real master, then we have the region repeater, and what that one does, every time it replicates an index, it just pushes the new index to an S3 bucket. This is what it does, and then it's done. As far as Solr replication goes, this is the setup. Replicates from the master, pushes to an S3 bucket, done. Then we actually use AWS. What we do, we go to those S3 buckets and we enable replication and versioning, and then it replicates across different regions. So we push this to EU Central, and then EU Central replicates to the US, to Ireland, and whatever, and we make sure that that data, those indexes, are actually available all of the regions. Then we run the Solr fleets, which instead of replicating from a real Solr repeater, they get a notification, oh, there's a new index version, but instead of using the replication mechanism, it goes and fetches it from the S3 bucket. And as you know, S3 will just scale. We don't have the previous issue anymore. And that's it. From there on, we have the shop public API hitting those auto-scaling group for the slaves. Not a problem. Actually, there is one. This is tightly coupled with AWS. It really depends on S3. It's easy to operate. We actually picked this solution because it's really easy for us. But in the meantime, there was some other person working on something that didn't depend on at least so much on AWS. And this is a little bit more complicated because it actually orchestrates a bunch of things. Mostly DNS. What it will leverage is DNS to solve the problem. So going a little bit back, as you remember, region repeater. That one is always present, and this is always part of the solution. This is how we replicate over the internet from our data center to AWS. So we start there. But from there, it becomes different. What we do is that we keep a CNAME, a DNS entry, pointing to the repeater. Just points to the repeater. And this is a CNAME to an A record, which is the current layer, the top level layer. Right now it's layer 0. It's the one single repeater. And then we have the auto-scaling group, the slaves. What they do, they replicate from repeater. And then, eventually, we set up the auto-scaling triggers. And these are configured in a slightly different way. What they do, they actually monitor the previous layer. And when the previous layer is exhausting its resources, either network, CPU, or whatever, what we do, we create a new layer. So instead of just scaling one group, we create a completely new group. And after we create this new group, what it does some quick math. Oh, what is the current amount of layers? Oh, it's just one. Then it creates layer 1, and then it switches the CNAME for repeater to now point to layer 1. So then there is some logic there of the amount of nodes that the group is created with, usually the existing amount plus some threshold, and this makes sure that we are just scaling in a pyramid. So we actually create layers to sustain the scalability of the last endpoint, which is the shop public API. I actually said this was a bit complex, but if you think about this, it's just basically Tinker Toys, right? You are just changing the pointer to the topmost or bottommost layer to replicate from. And eventually, we insert layers in between, making sure that each layer can replicate perfectly from the previous existing layer. This is it. This is actually it. We still have a bunch of minutes, but this was it. I always go too fast on this last topic, but this one usually triggers a lot of questions, but there is none in there. But this was it. So I'd like to thank you for listening, to being out here today. Hopefully now you know a little bit better who Zalando is and what we do, and we'll be open for questions. Thank you. Thank you. Right. Should we switch to that one? Well, if there is none, I don't need to switch. If there are no questions, I don't need to switch to...
Okay, go ahead.
So regarding the move from your data centers to AWS, you mentioned that operations were the key, you mentioned operations as one of the reasons.
One of the reasons, yeah.
One of the reasons. But is it really that easy? Because it's all different other infrastructure and things like that. You still need operations to operate the AWS services and things like that, DevOps.
Mm.
So can you just...
I think that's
Should I?
Yeah.
Yeah. Actually, there was a big chunk of information that we didn't include in this talk that is relevant because I think it answers your question. So I believe, to summarize your question, is it actually simpler to run stuff, to operate stuff on AWS?
I know it's simple for a small company, but when I see a large...
The dimension of Zalando?
Yeah.
Right. So
well, what you have to think of is that we won't have monolithic applications on AWS. We will have many small applications, and they will be operated by small teams. So for every small team will in future behave like a small company. So the team is in charge of operating their own small applications. So your logic for a small company applies to this new structure we have.
those teams are autonomous. This is the part that we didn't cover in this talk, is that at the same time, the paradigm shift led to another thing, which is radical agility. Radical agility is Zalando technology approach to run a tech company. And now we have teams from 3, 5, 10 engineers with almost full autonomy. They are fully accountable, responsible, they build the stuff, they test it, they deploy it, they operate it. This makes sure that we are effectively running a bunch of startups inside, right? All of them want to put their stuff there, to operate it, and this is what guarantees that this is working.
You first went Solr and then Memcached, but what about the Postgres instances?
That one was actually solved before. We created another SOAP layer in front of the database, but we did that before, still in the data center, because we had across data centers reading from that database, and this was not cool, so we actually created a service layer, a web service layer in front of that, still in the days that we were doing SOAP, so it's still a SOAP service, but all of the stored procedures that we were calling from the database basically had a map directly to a web service.
And the database, dependencies were not latency critical.
Yeah, because we only load that. Actually, for the fashion store, it's just used to persist stuff for caches. So we load it on startup, and it's not latency critical. I should have said that.
Will continue to host Postgres instances, or is there a plan to move them to the cloud or migrate to another?
As of today, Jimmy is about to die. We should have called it Kenny. As of today, and I'm actually part of that team, we started 3-4 months ago. Finally, the company set up a virtual team to make sure that we could put Jimmy to rest. And what we did is actually we came up with a new, completely new architecture to have a web application, and that web application is rendered at the end with a contribution from N autonomous teams, including putting their own markup with a real ownership meaning. This is probably the topic that will probably bring us here next year or whatever. So next year, I'm pretty sure that we'll be doing rounds across the world, showing this stuff that we came up with to the public. Thank you.
You were mentioning latency a couple of times.
Yes.
How Java and garbage collector performs in your case?
You mean with Jimmy or?
With the new API, because I assume it's Java.
It's actually not a big deal. It's actually not a big deal. I mean, I'm not part of that team. I work very close with them. They are really highly skilled engineers working there, and they profiled several times that thing. We even fine-tuned, for example, batching the stock requests up to the maximum transfer region of the TCP protocol to make sure that we could get more stock information as fast as possible, and garbage collection was never an issue there. Well, there was at some point something with Jackson serialization, but we even fine-tuned that. But we never actually had any real issues, but yeah. Yes?
Do you have plans to spread in Serbia?
This is
we're the engineering, you know. The truth is
that's the problem is. Yeah, we don't know. We're from engineering. At some point 3-4 years ago, we were aggressively growing in Europe, and we had already plans to expand to Russia, to Turkey, even to Australia, I think, at some point. And then management said, "Nah, we actually want to consolidate what we have." I don't know if that will ever change, but it will kind of change because we're opening our platform, and when we're opening the platform, your local Serbian guys can use our platform to sell you stuff. That perhaps is the way you will be affected by us in the future.
Let me ask you, was your question about if we will expand to Serbia to sell stuff, or will expand to Serbia and set up an office here to have engineers working for us? Both. Well, the answer is still the same.
But
because it's not our call.
But the second part is probably more likely than the first one.
We actually already opened tech hubs in Ireland, in Dublin. We also opened very recently in Helsinki, Finland, and we have at least 3 big ones in Germany, Berlin being the headquarters where we come from, Erfurt, where we run one of our biggest logistics centers, and Dortmund, where our payment PCI DSS compliant stuff runs because it needs to be outside of the rest. I know the expansion team is working hard on finding new places where there is a big talent pool, and depending on other political and economical conditions, they will definitely consider Eastern Europe because it kind of makes sense, but that's my own personal opinion.
And this is again about scaling, because I mean, we as a tech company need to scale. So we are currently at 900 people in technology alone, 9,000 in all of Zalando. And our plan is to scale to 2,000 engineers by the end of 2016. And that is a very ambitious goal. We're actively recruiting. I think last month we recruited 70 engineers in 1 month. So I think we're well on the way. But eventually, Berlin will only scale that far. So not everybody is willing to relocate to Berlin, even though Berlin is an awesome city.
I relocated there.
Yeah.
It's awesome.
Yeah. But still, I mean, people have families, people like their country. all of that. So we will have two different strategies. One is Berlin will always be the center of development, but we will also open hubs in the different parts of Europe to keep people closer to home.
No new questions there. So if anyone still has a question. No? Good. We still have 5 minutes, so. I should have more than that.
Yeah.
Okay, so that's it, right?
Okay.
Okay, thank you very much all for being here.